Controls. I'll be going over the building management system today and the user interface that you guys will be using to monitor, look at trends, look at alarms, and just check the health and status of the system. With the network structure right now, you have to log into it from this PC or the laptop that is over in building 55. They're on a private network, and that is more of an IT thing than anything to do with us. So to start, right now, this computer has an account called admin. Right now, all the passwords are set for the same. I'm not sure who will be administrating this system, who will be in charge of assigning user names and accounts to people and what access they can have and what they can do. But for right now, there's a login for the computer itself, and then there's 3 different levels of the system login. There's an admin, a power user, and just a normal user. And I'll go over the differences between those when we get to that point. So right now, to log into this system, the password is for the admin account is capital PASSWORD 1 exclamation point. So password 1 exclamation point with a capital P. We do highly recommend that this computer not be used for anything else, not for emails, not searching the web, because this is the server. So any viruses that can get on it, and actually, in our ideal situation, that you wouldn't even use this to log into the system, that this would be a standalone, but this is how the campus wanted their system. So from here, there's just a few icons. The main icon that you guys will be using, and the majority of the users will only need to use, is this icon I put here. It's the building management system UI. And all this is just it's a Chrome browser that I just that goes to the login. It will bring up whatever the last user was. So there are three different users. There's admin, all lowercase. There's power user with a capital U, and user, all lowercase. The admin has the rights to go in and change settings in the system and create users and assign them permissions. Power user has the ability to go in and override points and set points, but they do not have access to the more of the background side of the system. And the user only has view-only access, so they can go in and look, but they can't change set points. They can't override things. And there's and we will go over how to create new users. We do always recommend that everyone does have their own user. That way there is some accountability. That way if someone overrides, say, a compressor on or a pump on and overrides valves off or whatever, there's some accountability of who did that, versus if everyone uses one user account, it's hard to know who was the person who maybe caused damage or damage to the system one way or the other. So we will start with just the typical user, and we'll go over kind of some of the navigation. Actually, I'll start with the power user. That way you guys can see, because it's essentially the same thing. They just can't invoke any what they call actions. And again, the password for these are currently the same, capital PASSWORD. Basically what we have here, this system is looking over 3 buildings, the dining hall and the 2 new student buildings. It is all one system. And the way the system works is this computer works as the supervisor or the server, and through the IT network, it goes and talks to what we call Supervisory Controllers, or JACEs. And there are 5 JACEs in each of the student buildings, and 2 in the student center, or not student center, the dining hall. There are 4 JACEs that have to do with the HVAC systems. There's one for every other floor in the main buildings. In the dining building, there's one JACE that does the HVAC system, and then each building has another JACE that's just for metering, whether that's connecting to the power meters, water meters, gas meters, BTU meters. That's where all the data goes for the metering type of devices. The JACEs themselves, so there's 4 in, so we'll just, for right now, we'll just talk about, say, building 74. There's a JACE in the first floor mechanical room, and that first floor mechanical room JACE communicates over what they call a LAN network to LAN controllers. I'm not sure if you guys are familiar with a Niagara type system or Distech controllers at all. I know up until very recently, LAN was a standard across the campus. So these buildings are all LAN minus some devices where they're Modbus or BACnet, because either the meter or the drive or something only came in that type of communication. LAN has lost some of the ground in the industry as far as what they cover, so a lot of devices like meters and drives aren't offered in LAN anymore. So each JACE has 2 LAN trunks, and there's a LAN trunk per floor. So it's not like say the north side of one building's floor 1 and 2 is on one trunk. It's an even floor per trunk. Most of the floors are around 50 devices, or just under 50 devices per floor. The buildings 74 and 73 from floor 2 through 8 are essentially pretty identical, and between the buildings there are some differences between the systems on the first floor of those buildings, and then the dining hall is very different. Most of what we have for controllers in these spaces are what they call Distech ECL 103s. They're essentially one of their VAV controllers without the built-in actuator or pressure differential sensor for a VAV, and they're controlling the fan coils for the rooms. And then each room has a room sensor that communicates using a RJ45 Ethernet cable to it. It's called a Smart View sensor. There are some slight differences between the dorm rooms and the common areas and infrastructure. Essentially, the code is pretty much identical. Some of the differences is basically the way the fan operates. In the infrastructure rooms, the fan runs constantly, and then it opens the valve as needed. In the dorm rooms, the fans do not run constantly. Well, sorry, I misspoke earlier. They don't have the Smart View sensors in the rooms. They are this job is a different type of sensor. But it still communicates on the RJ45 Ethernet cable. But in the dorm rooms, the fans only come on a heating or cooling call, and they will speed up and down if needed, but they'll start on low speed unless the occupant turns their fan from automatic to one of the 3 speeds. And then they have occupancy where if the window is open, they will not operate.
Where is that wired to? Is that actually wired into the Distech control?
Yeah, it's actually wired to a DI into the Distech controller.
And that's something we can control from here.
As far as
if we wanted to override that or anything like that, just wondering for the sake of.
So there are ways to do it, not through the graphic interface,
right,
but actually through, and we'll go into how you get into the code of a controller, and the points and everything like that as well. Okay. Then some of the other controls we have are what they call ECL, the 450 and 650 series controllers. They're more for central plants or air handlers. Building 74 has a single air handler with VAVs underneath it. Or actually, no, 74 has two air handlers, AHU 1 and 2. Building 73 has a singular AHU with VAVs underneath it. And that's essentially the differences. They both have their own heating system for each building with 4 boilers, 2 pumps, and dual skids for the domestic hot water that comes off the same heating hot water system. And then they have a booster pump system for the chilled water as well. Basically, so the booster pumps will, if we're not getting enough from the plant and the DPs drops too low here, then the booster pump will kick on and help get the water out to these far out buildings on the plant. The central plant is going to tie in to monitor the DP at these buildings, and they're going to try to make it so that that isn't really ever needed, but that's outside of our scope on this project. We just give them access to those points.
And now you were talking about the admin level, the power user level, the user level. So how are we designated? So we're taking care of building 73 and 74. Of course, we have nothing to do with 72 and 72. Whoever's taking care of that, foundation, they have nothing to do with our building. So when we log in, are we going to be able to make changes to building 72, and vice versa? Are they going to be able to make changes to 73 and 74?
So right now, I believe the way the system is set up, there's nothing that would prevent that from happening.
Right.
That's one of the reasons why I say that there should be different users.
Yeah, and that's the problem. Who's supposed to, are you going to set that up, or is someone else going to set that up? Or...
So that was not part of anywhere in the scope or anything to kind of split the job up in that to users. It can be done. It's pretty time intensive to split those up, especially with, but that's definitely something that can be done. And if it's something that is requested, it might end up being a change order. That's kind of outside of what I can ask about that. But yeah, so right now it's one. The issue is it's one server. And even if they're connecting from over there, they're still connecting into this one server.
Yeah. So in admin, are they? And you said that they can appoint users. Are they going to be able to limit the access? Like if someone's an admin, limit the access of those users or power users to where they can't touch the other buildings or something?
It's not through a user setup. We would have to create different user templates. Basically, I created 3 user templates for someone to use, so they can just duplicate it, where those access rights to view or read or initiate or create new users are separated out.
Say like I make an account for Jim, and we call it whatever. We can designate him as an admin, a power user, or a user. Correct?
Yes.
So it's as simple as that. Those things are already in the system, so you can only do that, and it gives you access to, the user is access to see everything, the power user is to adjust everything, and the admin can do everything.
Yeah.
So
I understood that.
But But I mean that can be done, but it's like I said,
Some
there's
templates
a
are
lot.
already there.
Yeah,
Right.
templates are there for these type of
Yeah.
broad, and it's more of a, and also like if they have an admin, there's nothing that we could do to stop an admin from going in and accessing anything else either. The read only really can't do anything because you can only look. You can't change set points or override points. And really it's the power user, I guess that would be the concern, the person that you'd want to be able to override points, but you don't want them messing with the other building here and there. And I don't know so much the dynamic between you guys and the foundation.
There is no dynamic.
So
Okay.
basically, they'll be able to give access to whoever. It will be
Yeah.
And that's the thing,
Run their
if they
own.
have a user, if they have an admin account, they could just
Yeah, that's why I'm driving down the street right now, because you were talking about, accountability, and we have nothing to do with them, so there's no accountability between the two, and right now, at this point, I see this just being a problem, but.
But so, and the other thing too is no matter what, if you guys had your own admin and they have their own admin, either of you guys could then create a user that gave access to someone else
Right.
to the other site or vice versa. Yeah, so the admin level, there's no real way to, because it is one system, so it's an admin of this one system, and unfortunately that's just how it was. If it was something where in the original design or scope it could have been separated out, and that's not to say that theoretically it could still be separated out if someone wanted to buy another server, and then there'd be we'd have to then divide this whole
Yeah.
up, but it could be separated servers, and that way they wouldn't even be tied together at all. But
So I'm understanding that somebody from Foundation would go in and just
Or shut everything off in our buildings if they wanted to, or turn everything
or even
on.
by mistake.
I mean, they probably wouldn't, but
I'm just saying, even if
yeah,
it's a
but by
mistake type
mistake, or
so we could have issues,
yeah,
or vice versa, even I guess. in a
right,
sense.
vice versa. We could do the same to them by accident or something. Or,
there are logs for what is done.
yeah,
And again, that's why I stress the whole different users per person. That way, it's not just this whoever was using the user account did it, and then no one it's like, oh, I didn't do it.
yeah.
Jim didn't do it, Bob didn't do it. I don't know.
Well, technically, users wouldn't be able to, right? We
Oh yeah,
can do-
technically user.
Jim just wants to be a user.
Yeah. Jim probably won't actually use this. But
I don't even know if there is a Jim. I just pulled Jim, Bob, random names. Okay.
I go by Jim Bob.
But when you do log in, this is what you'll see. You'll see a campus overview map, and so there's different ways you can click. You can click each building here on the map, or you can click from the list here. We will start with 74. When you go into it, it's going to bring you to a summary page. So there's a summary page for the building, and then per floor. So we can see right here that it's showing right now that there's a active boiler alarm in one of the boilers. Boiler 2 is an alarm.
Nice.
that's not nice.
I don't know why boiler
Yeah,
2.
yeah.
We're just reading it. It's one of the things we never want when we're showing you guys stuff, for there to be alarms. But sometimes it's
Sometimes it's a good thing.
if a boiler is an alarm, it's an alarm.
Yeah.
I guess it's doing its job.
Yeah, it's letting you guys know.
And each, before we get too far, each
Yeah.
Jace that's for basically 2 floors of that building.
Yeah.
Are they all in the mechanical room over there?
No.
Or they're on each
So,
floor? Second, fourth, right?
First
Maybe
floor.
They're on the.
I know it's
pods.
4th floor and 8th floor for sure. I'm not sure the middle floor is where they're located.
think
I know
wrote it
there's.
down, but I was just trying to refresh so we can all remember.
Yeah, I
where they
know,
are,
and I can verify too what floor, but I know the middle 4 floors, the Jaces are in one spot together. They're in one of the IDF rooms.
Maybe it was just 4 and 8.
Yeah, it could be 4 and 8. So there's 3 locations in these buildings, the ones you guys are concerned with. The mechanical rooms have the JACEs for the 1st and 2nd floor and their the building mechanical systems, minus the 8th. And then they also have the JACE for the metering, which they requested be separated out. And then the 8th floor does have another controller that has some more exhaust fans on it. But other than that, most of the floors from 2 through 8 are pretty much identical.
There's nothing we would actually do at those JACEs, right? Like
The metering
change
ones?
Yeah.
Yeah, it's just more for, and I know
Like a communicating.
It's more for, so if we lost control to like all of one floor, then at least we would know where it is. You know, we could go look and see if there's lights on it, see what it's doing, if
Yeah.
there's air with it, or we could try to, you know, half of the time you unplug it and plug it back in to try to get it to reset.
Yeah.
And
see if the network lights are on or
Yeah.
off on it.
But you rarely do that because you haven't done it now, right? No. So we've never had a problem.
What's a Jace?
but there's
It's a little box.
Yeah,
It's a
we
lot
can,
of
we can,
yours.
and at some point when we,
it's basically just
I
a
get tired
controller.
talking,
Controller,
we can
okay.
walk
Just
over
The sensor
and,
sends
like
to
a
it
brand
and then
name or-
communicates to this.
Is
yeah.
that like a brand name or is it just a
No,
code?
it's
So
just
a JACE is called, the JACE stands for Java Application Computer Environment. These are Distech branded JACEs, so they're technically called an EC Boss 8. They run Niagara N4, which is the 4th version of the Niagara building kind of database system.
Would that make it more clear for you?
A little bit.
But we,
At least I know.
when we need a break, need to walk, we can walk over to one of the buildings and I can show you one of the panels where one of the JACEs are, what they look like normally, functioning.
That'd be cool.
And then I can show you also the controllers and how on the larger ones they actually have overrides directly on the outputs that you can override. So when you log into a building, you will first come to a building system, and from here you'll see stuff like the chilled water system, the hot water system, and the exhaust fans. From here, anything that you mouse over and highlights this darker blue shade, that means that there's an action that you can do. So if you right click on that, it'll bring you up a list of actions. So on these ones, so anything that doesn't just say like a set is an override. So this is, we can override it enabled, override it disabled, or release it to auto. And then when we override a point, like I'm just gonna, so one, you can override it and you can give it a custom time for how long, which is handy. I always recommend doing that, even if it's for like 2 days, because you can do a custom time. That way something doesn't get overridden and left, whether you're doing some sort of test. So like here, I'm just gonna put it to 15 minutes, and I overrode it.
So once it goes out of that 15 minutes, then what will it go back to?
It'll just go back to whatever
what it was
normally,
previously, or
whatever. So when you're overriding a point, that is a point that has something else in the code writing into it,
Right.
and you're taking priority over that input. So when it releases, it would be whatever's writing into it at that point. It doesn't matter what it was; it only matters what's writing into it at that time.
And is there something that lets you know it's been overridden?
Yes. So if you see here, now that point has turned that purple color, which in this help you can see right here, that magenta purplish color.
Lavender? No,
Point overridden.
Fuchsia.
Fuchsia. Yeah, I'm not good with colors and names. I see it's like purple, close enough to me.
What's it say? Override, you said?
It's yeah. So that means the point's overridden. And this pop-up is accessible anywhere from this help button. So you just click that. There we go. Oh, there's blocking the pop-up. Always. Oh, okay. This pop-up's available anywhere. And it'll kind of tell you what all the different colors mean, what some of the icons mean, and then there's also our 24-hour service phone number and email address.
You could end the time frame whenever you want.
I'm sorry, what's that?
Like that 15 minutes, you could stop it whenever you want.
Yeah. So also, if you So right now that point's overridden. We can just click auto, and it doesn't matter if I had it set for 5 minutes, or auto will just go right back to auto. Yep. Other things you might see where the mouse goes over and the pointer turns into a can showing you can click on it. That means if you click on that, it'll bring you into another view, another window, whether it replaces the window you were looking at or brings a pop-up. So this is just one example of that, and we'll go more into detail on different systems as well. Let me see here. I did just want to show you an example of, so you can see right here, there is a set. So a set is if a point does not have anything writing into it, and it's just a value that goes out into the code basically. So like this is the stop delay for the pumps. We would set that. That's not overriding, that's not, if I, I'll show you. If I set that to 10 minutes, it's not going to give you a how long, like an expiration, because it's just, there's no expiration. This is just changing a setting. Change that and then it'll just change. There's no way for you to know that a set was changed because it's just that singular type value.
I understand what's a set, sorry.
So a set is basically, in the code, a set would be like the starting point for that value. Or something that you're overriding, something else is writing into that value, that point that we're displaying. But a set would be just like a value going into like, I say a temperature set point, where nothing else is changing that in the code, and it's just you want to change it from 70 to 72 would be a set.
Oh, okay.
Like this is a pump stop delay. So nothing in the code dynamically changes that. It's just like a setting value. So that's the difference between those two types of actions, the override and that.
So there's no pre-hard set on those set ones?
No, when you change them, they're changed, and that's it. There are, now the override we looked at earlier was a true or false, like an on or off command type. Now this one here is a value. This is what they call a numeric value. So it's a number value that can change. So there's no, on or off for that, and you only get you get two override options here. You override the actual value versus overriding it to a state of on or off. And it works the same way. So the override expiration, and it has the auto command. And the point still turns purple, just the same as the other ones. We'll go more into this actual system. Just want to kind of go over more of the basic navigation. From here, from the systems, which is the building homepage basically, going into it, you can click on individual floors, and then you can see what the systems are doing. So the first floor is going to have the most kind of unique setup, because here we have, like on this one, we have the two air handlers and their VAVs. And then we also do have some fan coils as well. If you look here for space temperature, you can see that this room right here is the colors turned like a reddish color. That's to indicate to you guys as a user that the temperature is above the set point. It may not be an alarm, but it's just turned slightly redder, and it'll go a deeper red or a lighter to clear basically, based off how far above set point it is. Down here we can see some of these where you can see kind of different shades of the bluish tint to the space temperature to show you that these are slightly below temperature. From here again, you can click on any of the units names and it'll pop up an individual unit graphic as well. And for like the VAVs, the damper will move depending on the position. The heating valve will show the coil. And then from here, it is shown in the help, this circle with a little line graph inside of it. When we are looking here, we can click on that and it'll pop up the history for that point at that unit. And from here you can scroll out, you can do a shift scroll to stretch it. A shift scroll stretches the timeout. A normal scroll zooms both values out on the graph.
Would it let you know, like, for instance, if that damper controller doesn't work or it doesn't move, will it let you know, or will it still move on the screen and not actually fit? You know what I mean?
So these are based off of off the damper. So there is a damper command and a damper position. This is the damper command point. When we put the mouse over it, it'll kind of show you like a point name, and it'll give you a little bit more information. It'll tell you like what the value is, and that default means it's not being overridden, basically. If I were to go over here and override that to say 30, and it may take a second for it to show, because basically what it is sending a command from here to the J's down to the lawn controller, and then the J's needs to read that point. But we can see here that it's saying that its damper command is actually at 30%, and it's overridden at 8, means it's a priority that the override writes at. But this point here is actually based off of the damper position, which is a dynamic feedback that the controller determines based on basically steps. It will zero out every once in a while, and then it kind of keeps track of where it is and knows. But if those values aren't matching in a certain time, it would show an alarm and shoot to the alarm console. You would also get an alarm, most likely because the airflow values would be off, and that would also send an alarm.
Is there a static, or not static pressure, but is there some sort of something that's measuring flow inside of each one of those VAVs?
Yeah, so each VAV
controls.
has its own flow sensor.
Okay.
It has basically it's a differential pressure sensor that looks at the downstream pressure versus upstream pressure, and it uses the box size and what they call a K factor to determine basically what the flow is by those values. And we'll go more detailed into the VAV boxes as well. Some systems, like just the exhaust fans, where these are literally the only points, we don't have an individual graphic for those, because everything you want to know is here. Where like a VAV, there's more to it than just what's in that box. And then you can also get to settings and things to that. Each building does have also a global settings, where if you were to set these values here, it would then go and set it everywhere for every one of those. Like, so right now this is for every VAV. So if we changed
Every VAV, not the air handlers, I guess.
Yeah.
Not the,
well, because the air handlers are so individual, they're basically one-offs. But these are more like at the zone level. So here we have every VAV, every common room fan coils, the dorm fan coils, the infrastructure, and then we do have ones for every fan coil as well. So these would, any of these would go and do it for all of the fan coils, and then it's individual ones. We have the air handler values here. We have some zone statistics here for the air handlers, so you can see what's the warmest and coldest zone and what's the greatest error, basically. So this one here, VAV 112 right here, is 3.8 degrees above set point right now. We can see the greatest negative over here is 2 degrees below set point, this value number here.
And those are for each air handler.
For each individual.
Those are designated, yeah, whatever VABs
Yeah.
are tied to each air handler.
Yeah.
Okay.
And then we do have some fan coils here as well. And here, there's just one of the fan coils. So you guys can see it now, what it looks like.
So you can view each individual residence room fan coil from
Yep.
that?
So right now, this is the first floor. So there's no resident. This is the the apartment one there. If we go to the second floor, actually, what I can do too, if it makes it easier, it'll be a little. I can actually zoom in a little bit,
There you go.
and I'll just scroll just because I know there's limited space. Some things may look a little weird zoomed in like that, but basically the second through 8th floor is basically the same. You'll see an exhaust fan. Most only have one locally per floor. I think floor 8, no, floor 8 only has one here too. And then you have a list of the fan coils, and then it will list what they serve. And you'll see some things like this living room here, where you won't see the set points here because they're shared units. They all work off of one set point. Same thing, you'll see the temperature swings here. There's things that you can override, you can set. Like the fan command. If it's set to off, that means someone's actually turned the knob to off and it would just not come on.
And we can set that back to auto if we want.
Yes,
to,
it
right,
can be
for
set
here, correct?
back to auto. So we can go here and set. There is a global command too that will go out and set every fan coil to back to auto. So it's temperature to, not offset one way or the other, and the fan to auto.
So if these buildings are vacant, can you go in there and turn them all off?
Yes. That is in the global options. So say you could go to the dorm rooms, you could set them all to not being occupied. All fan coils, you can actually disable the system,
Shut off the apartments. Also.
and that would every fan coil would be disabled.
So not if you go to the floor. If you go to the second floor, you turn all those off.
So you could go to
Yeah,
each individual
have to go to
unit
each individual
and do it.
These global commands, if you do all FCUs,
Yeah.
which he was showing us, that'll shut off the coordinator's
Yeah.
apartments too, is what
I'm
saying.
talking about, student rooms.
Yeah. He
Yeah,
has
so-
them in global
yeah, there
for
is-
student rooms.
Yeah, you call them just dorms.
Yeah, the
Yeah.
dorm fan coils.
So there you can set it to basically
Unoccupied.
You would uncheck the occupied.
And I think you could set the supply fan to off to. There's a few different ways you kind of get the same results. And this is a set. So say there were 10 dorms that were going to be used during the summer for whatever reason. There's people that were going to be, some sort of internship, and they were being housed there. You could go set them all off, and then just go to those individual ones and set them back, because it's doing a set to everything, and then you can just go after you've done the set to everything and just turn those individual ones back on.
Yeah, because if we set it from here with that global command, say if we set it to unoccupied, if you go to the stat in one of the rooms and you turn it back, will it turn on?
So if you turn it all off from here, say you set them all off,
Right.
then it would. And then if you did that, and then it would come
it
back.
would turn on, right?
Yeah.
So if someone's in there messing with it again, we can't lock it out from here where you couldn't turn it on at all from the other side.
So the system enable for across the whole thing, that's a higher level that's not
Okay.
involved with the stat,
Okay.
but that is across the entire. But then you could go to each individual ones and turn on just like a handful if you wanted.
And each one of those smaller fan coils, like in the resident room, will tell you air pressure, static. They have those things, because I'm just wondering if we'd be able to tell if a motor's not working. Or...
So we do have fan status.
Okay.
There is no.
They have temperature. They don't have pressure. I don't think.
Yeah. And normally when things are zoomed in, you wouldn't have to scroll. But we have the fan status. You can see what the fan command is, the valve commands, and the supply air temperature. These we do not control an outside air damper for these. They were all hand balanced for a minimum outside air. There's no filter status. There is a runtime maintenance reminder. Let's see, somewhere in here.
On the right.
Yeah, right here. So right now the alarm threshold for the maintenance reminder is 10,000 hours of runtime. I don't know what you guys would want that to be. It can be changed.
So with that
whatever.
fan status, it would actually know if that fan motor's not working.
Yeah, and it would send an alarm. So if we're telling the fan to run and it doesn't respond within a certain amount of time, it would shoot an alarm saying, "Hey, this fan is not working."
Because I've seen some old systems where it's still on the computer, it's still spinning, but it's not actually.
Yeah.
working.
So and this fan status, that's the fan status. I mean, you could have a sensor that goes bad, or something could happen to the wire.
10,000, I guess, if it runs 24 hours a day, that's a little bit more than a year.
Yeah.
So yeah, probably less than 10,000 would be best.
And then that's something that we
Change it
can-
once a year,
yeah.
maybe at least.
Yeah.
But
And
you
then-
can adjust that
Yep.
from here.
And
right?
it can be adjusted globally across
Yeah.
all of them through that set.
And then if we were to replace like a valve or a water valve or anything on there, does it have to be learned to the system or it'll automatically?
No, it's just
pick it
as long as it's the right type of valve. These are all I think 0 to 10 volt DC modulating valves.
Okay.
They're not open or closed valves. They modulate to, and we do that to maintain a supply air temperature.
The controller, of course, on each one would be a different story.
Do you get
Possibly
any
they need some
feedback
sort of,
to the computer? Let's say, for example, the students don't know better, so if they open the window, the system's going to turn off. Are we going to be able to tell on the computer that the window's open? Or
Yes, so there
turn off?
we do see a window status.
Okay.
We do have a condensate level alarm as well. So if condensate drain backs up, it will also then shut the unit down from running, close the valves. And if that tripped, that would give you an alarm as well. Also, if the fan is running and we're not telling it to run, it would give you an alarm as well, saying the fan's running in hand. If it doesn't run, it will give you a fan failed to start.
How are we getting fan status on that supply fan?
It is a current switch.
Current switch? Okay. Is that something that was field installed or?
Yes, field
is that-
installed.
Okay.
There is another icon here which I don't have, but it is shown in the help menu where it's a little circle with a wrench in it. So the way that the dorm rooms work, the supply air temperature resets. Sorry, everything's kind of weird sized right now. So it resets based off of what mode it's in, heating or cooling, and the demand of it, and it will change a 1/10 of a degree every 2 minutes. The idea is to kind of get these to run more efficiently with less complaints from the occupant, kind of like how like a split unit runs. It doesn't just come on like an old train unit, compressor 100%, full cooling, then shut off, blows the 50-degree air for 10 minutes, shuts off. The idea of this is to keep it so that maybe it just needs to discharge 69-degree air to keep the room 72 degrees in the summer, and it will just sit there and just keep maintaining that. So that way it's not all of a sudden the unit's coming on, blowing cold air down on the students, they complain, you guys get complaints, you have to deal with it, have to deal with them.
They complain if they
They'll complain anyway. You know, it's one of the things you
fill
can't.
the cold air. That's what we'll get more so is what I'm worried
Yeah.
about with this. But you know, it is what it is.
And again, these set points can all be changed too, where you know you guys wanted to in the future, you could change it so that the initial set point was 55, the maximum was 55, and the minimum was 55, and it would just never
55 degree
always
air all the time.
whenever they went into a cooling mode.
Yeah.
So those can be
Then it'd
changed.
like the old school. Yeah.
And the valve does modulate to maintain that discharge air temp. And that is something where, you know, and with this system, you can do that. It's not for every unit. So if you have one student that makes that complaint all the time, you could just set theirs up like that and then not have to hear from them again. And
Yeah, clean it up after
Yeah.
you leave or something.
yeah, because then afterwards you could just reset the whole building back to the normal and go from there.
Somebody's always gonna bitch.
Yeah. No matter what,
No
there are
matter what you do.
people, no one's ever happy. Just go on the internet.
They're recording you.
I don't care.
If for whatever reason they change dorm number, you guys can go in and change these. But I would be cautious against that because if you, so if I just went through and like changed all these to just some other random number, it would be a real pain to go back through and figure out where they all are.
Oh, them say
So-
room number. That's
So again, here we
Yeah.
come to the point of, you know, a lot of other people have access to this. What happens if someone, you know, starts going in there,
Mhm.
you know, maybe someone's getting fired and they don't like, you know, they want to, you know, who knows, but
Yeah.
it's kind of crazy that they decided one system for all this stuff, so.
Yeah.
you mean between foundation and us.
Yeah.
Yeah, that's cool.
But let me zoom back out right now. The normal view.
One more question: is there a central location where it gives maybe a log of what everybody's done, or where somebody can go in and make notes of what they've done, like it?
So there are
Like where it's kind of like you can just go to one place and say, oh, so and so did this, so and so did that, so and so did this.
so there are histories.
And if you were gonna visit that, then I'll wait. But
Let's see here. I don't think through this view they're exactly user friendly, but for the admin, where they go into through what we call a workbench, they can get into more background stuff. They can actually go into a history mode, and they can where is history? It should be there. So that is because we have the alarm console up on here, is basically saying, hey, there's alarms. This is just an alarm noise. Let me go back to that after. So there are alarms for, maybe they're not brought in here. Or sorry, not alarms, there are histories.
Let's see, not easy to really look at the history, I guess, right?
So here we can see these overrides and who did it when. So we can see the ones that we did, date, time, and the user, and then what they did. And if so, again, that's one of the reasons why I said that different users and the accountability really helps.
Yeah, it's important, but unfortunately, like Foundation, they have their own management, and we have, so even though if they make us do it, doesn't necessarily mean that they're gonna enforce that with them, you know?
Yeah. Yep. Let me go back. So one of the other views in this top menu bar is the floor plan. So from here you can see a floor plan of the building. And then from here you can individually select a unit and click and pop up. I'll show you. We can see that this unit here, this VAV, is actively heating, so the coil is showing that radiant glow. We can see our discharge air temp here. We can see what the valve reheat command is, how much airflow command versus set point. And then it does list the unit that it's served by and what its status currently is. So you can see like right now that one's currently running at 64 degree discharge. And we can see that the hot water is running and the supply what the supply temp is as well.
So that one's in the business services area, I think.
Yeah, this one says
Lounge
Lounge 126. So it's right over here.
Next to the kitchen.
Oh, so that would be the other side then.
Yeah.
And air handler 1 in that building, where is it?
Air handler 1 is in the mechanical room,
Okay.
and air handler 2 is in the bike
bicycle
storage. The circles with the T represent the room sensor for that space to show you an accurate location of where that sensor would be. Sometimes not so much here, but you may have like a large area with one zone kind of covering and not sure where the stuff is, and then they put cubicles up and it's behind somewhere.
Yeah, they probably won't make any changes to this
Yeah,
building,
here
luckily.
you guys are
Some
kind of
places, yeah, they start taking down walls and moving walls.
Yeah.
And
So same thing here with the where we showed you that the temperature value reading would that background in the summary would go red or blue. So will the floor plan area for the zone. So we can see this zone right here
right.
is over temp. And the black lines basically represent the edge of the zones, because a lot of the time there won't always be a wall that represents it. So we draw the black line within the walls to show where the different zones start and stop. And then from here you can click on any of those, what we call the floor tags. You can click and it'll pop up the unit again as well, just like you're in the summary page. So there's a few different ways that you can look at the different building and the systems. And there's one for all the floors, and it's the same between the buildings. There's all 8 floors.
That doesn't have the black line so much, does it?
May not. Just
The upper
let's
floors,
see.
I guess. Just that first floor.
I don't know why that's not showing.
So it looks like there's no stat location on there either, right?
Yeah, let me see if this is something with the web browser just not loading correctly. Okay, I'll have to I'll have to talk with my guy who's doing the floor plans. We'll get that corrected. There is the next there's a schedules So this is for all the common areas, the VAVs and their air handlers. Right now the schedules are just set for 24/7. The way that you can change those, and again, admin or power user can only do this, a user cannot. You just click and drag. And if I want, I can add like another one. Let's see. Click and hold and drag another one. I can edit, you know. By default, if you don't have anything, it's unoccupied. You do have to click the save button for it to take effect. If you mess it up, you can just a little,
Okay. Yeah, it's a little
Yeah.
floppy disk.
yeah. Or if you go back, it'll ask, you know, if you, it'll ask you, do you want to save? And to say if you were messing around with the schedule and you weren't sure how to mess it up, didn't know how to go back, you could just go back, click no, and then go back to it, and then it'd be how it was. There is some energy monitoring points. I know the IT department still hasn't got it so that we can actually talk to the electrical meters. That's why you'll see that these points are this yellow. I think it's technically goldenrod, but it means that the point's down because there's a communication failure, and it's on the IT
See, those
system.
colors don't look like they match,
Yeah,
right? That
I gotta-
doesn't match with that, does it?
Yeah, you have to look at it.
Yeah, it's like goldenrod, and then the other one's orange.
Well, yeah, that's like an orange. So the orange is faulted, and that's yellow is the calm down. You have to look. We'll have to update that. But there are automatic set points in here to do a demand limiting based on energy usage. That can all be set here.
What do you mean by demand limiting?
So what it will do is it will shed by different levels. So right here we can see if you're on peak time, and this building goes above 250 kilowatts, then it will set back or set the temperatures off by 1 degree. So you know, everything was set for their base was 72 degrees for cooling. That first level limit would then set that base to 73 automatically, and then it'll keep limiting based off as part of the sequence that they asked for.
Who asked for it? Does the state ask for that for energy?
I'm not sure where it came from. It was just in the sequence of ops.
I was just wondering.
Yeah, I'm not sure who wrote the sequence of ops. But it is here. If it's something that you guys don't ever want to use, those can just be set to a super high level. That would never happen. I think it's more for the energy people in the building and everything to determine. That is here. And then there are, you can see the energy usage for the hot water, chilled water, gas meter, or the energy usage for the hot water and chilled water. I'll do a bar graph for each day and how many tons it used of cooling. And then it's million BTUs or mega BTUs used per day. And then the instantaneous usage through those days as well. The gas meters, the cubic feet, and water, it's gallons, which so far doesn't look like there's been any water being used throughout the building.
Only with floods.
Yeah.
That's what's under the energy tab. So we've gone over systems, energy, floor plan, schedules, the alarms. So the way the alarms will come in, they will automatically display through the time and the most recent. It'll give you a source of those alarms. The little icon, the info of the alarm bell, will either be green, and that will show you that this went into alarm at one point, and now it's out of that alarm state. Red means it's in an active alarm state, and like a gray would mean that it is still in alarm, but someone has acknowledged that alarm. From here, you can select a bunch of the alarms if you want. You can acknowledge them, force them to clear. If we're only selecting the green ones and we say acknowledge, once the green ones get acknowledged, they'll disappear out of the alarm queue. You can click to change how they're sorted by any of these different values. The text message. So let's take a look at this one here. So building 74, Jace, building 74, fan coil 712A, and it's saying space temperature deviation alarm, and it's saying that it's fault. The alarm data will give you more information. It'll say like the deadband, the fault value. So this one's saying that the sensor is not working. It's saying that the sensor is faulted and it's not reading properly, basically.
Yeah. So that'd be the thermostat.
So that could be that someone took that off. Maybe they're painting the wall or something, or one of the students horsing around, broke it off. So let's actually go and we'll take a look at that. So that's building 74, 7th floor, 12A. So we can go look at it through the summary, go to the 7th floor, and it's 12A. So we can see the color is orange. Well, it is an alarm, it's also faulted. So a fault is like an alarm, but it's saying that this value is not a good value. So it's not saying that it's in an alarm state. So like it's like a duct pressure sensor or filter status. Say that value was so off that we're like, that's not a correct value. Something's wrong with the reading. So it shows a faulted, and that orange represents a fault of that. So most likely this is that the stat has been unplugged, the sensor has been unplugged from the wall, whether they're painting, doing something, or it's been damaged.
And these sensors, to get away from the controls, I guess, these sensors, is there any kind of designation of how they communicate to this system? Or like say if we bought a new one and we just plugged in, is it gonna...
By default, it should automatically work.
Okay.
None of these have multiple sensors, so there's no, some of them would have like, by default, everything that we do, unless there's multiple sensors on one controller, out of the box will just plug in and work.
Right, okay.
And all the programming for it's in the controller, not really the sensor. The sensor is really just it takes a reading and the knob values and sends it back and forth. But there's no programming is in that part of it.
Yeah. The controller's another story.
Controller's another story, yeah.
Programmed probably
Yeah.
if one goes out or something.
Yeah,
Right?
and with lawn is kind of tricky to replace a controller versus BACnet.
Backnet, right.
It's just
So if
kind of a
if
different
we're,
animal.
I mean, going down this road some more, if we're replacing a control, then we're going to have to probably call Sunbelt, right?
Yeah, and I'm not sure what you guys have in house as far as control people.
Our controls are pretty basic right now.
Okay.
This is quite a bit a step up from what we have. So.
Okay. Yeah, I mean, and it could be a thing where if you guys wanted to, you guys could have some replacement controllers pre-programmed on the shelf. Like, you know, for all these dorms, maybe it wouldn't be a bad idea to have like 2 or 3 on hand that were programmed per the dorms. And then it can be something that we could remotely get in and replace it as well, with the help of the person who's actually doing it. With LAN has what they call a Neuron Id, which is unique per controller. Every single LAN device is supposed to have its own unique Neuron Id that's never been used anywhere else before. I'm not saying that that is actually the case.
Yeah, right.
But that's the word that they're all unique. So basically, there's some things we would have to know, you know, which one you're replacing.
Yeah.
You know, say this fan call. Say the sensor's not bad, but something happened to the controller.
Right.
You know, here.
So I need the
So
information off the
you
controller.
guys would tell us, you know, we're replacing this one, and then this is the new Neuron ID for the one we're going to put in, and then we could assist with that remotely. Again, that's still dependent on IT, and as long as they keep our remote access open.
Do you have remote access right now?
We do. It's very limited.
Okay.
Basically, and when we come in, we take over this computer, and then you guys can't use it when we're in it.
Right.
That's really the only access that we have, is they let us come in
Client share.
to this, and we can remote desktop to this, and then from here we can access everything else, but we can't directly access anything else.
So there's no remote anything from this. It's either here or the one computer that you set up for
Yeah.
remote access.
Yeah.
For
That's really dependent on the IT. Like, they could make it so you guys could look at this on your phone if they wanted, but it's just a matter of security,
yeah.
public IP addresses, things like to that extent.
It's really hard to deal with IT here, so
So like in here we can see, we can sort the alarms by their state. So right now, like, these are sorted by the off normal alarms, so we can see all the different things. Some of these alarms are the VAVs just get too cold for the space, but that's all. They're running the way they're supposed to be with their minimums and maximums and maximum discharge air temperature per the balancing and mechanical engineering. So we can't really go outside those set points. It's just what it is. We can see that there are some where they're saying some of these fans have failed to start. We'd have to go in and take a look to see. And again, this alarm console is going to be for all 3 buildings. The alarm consoles can be divided up relatively easily per building.
right now they just all come right here.
They all
So
come to
right
this
now,
one.
Going into an alarm that's just showing all the buildings right
Yeah. So we can see like
here. Number 72.
building 73. So we can see, that pump right there is showing an alarm. If we go in here, it says that it failed to start. I have found where we've gone in and found that someone has the drive off, or not auto, and it's in hand. We found a lot where a lot of the alarms I know were caused because they went through and replaced all the condensate flow switches, or float switches, because
They were
they're
not the right size.
they wouldn't have
They
tripped
wouldn't
until
trip,
after
yeah,
it was
until after
overflowing,
coming down.
which kind of destroys the purpose of them.
Yeah.
Another thing, just to show you, so if one of these pumps were running, this pipe would then highlight to show you that this is kind of the flow of the system. This is something we try to do to make it easier for you guys to do a quick look and see how the system's operating, which way it's operating.
So pump 1 failed to start right now. Is pump 2 running right now, or
No,
is
it's
it
not, because it's
being-
not actively trying.
Okay.
Basically, when it's failed to start, it will stop trying to
There's
run
no
it.
command from the fan coils maybe for chilled water.
So right now, basically, what it the sequence, there has to be so much demand, and the BP has to be so low for it to then
Right.
and go into it. In the chilled water and hot water systems, there you can see who's requesting, and you can kind of search through floors, and we can see right now no one is requesting an increase. Everyone's saying, hey, you can decrease as far as I'm concerned, basically.
So actually, there's a request for cooling in most of the building right now.
No, this is so this is a request that they're not requesting more. Basically, so this is what they call a negative request. It's
Okay.
basically saying I don't need it and I'm good. You can actually go back and I'd be fine right now.
Okay.
Is basically
I see.
now if we probably looked at the hot water system, that'd probably be a different story. It really is dependent on basically what we're trying to do is keep the worst case valve open between like 85 and 95%. So that way the pumps have to work the least amount, least restriction to get all the water everywhere it needs. So we can see like this one right here. This one is requesting
Increase.
an increase. And then you can
The
see
minus
which
one
ones
is
are.
not actually like degrees or anything.
No, that's
It's
just saying like
It's just a point.
It's so the negative one means you can decrease.
Yeah.
Positive one means increase. And it says how many. Basically, it's a whole bunch of settings here that were part of the sequence that say how you increase and decrease based on how many are demanding increase and decrease. And then from here you can go through and see. We can see like this one here is calling for an increase, and it's been calling for an increase for almost 400 hours, saying it needs an increase. It'll show you the valve position and the percent of time it's been running that it's said I need more. So that could be
About 400 hours. It's been running 94 or
403 hours. It's
94%.
requested 380 hours. I need more water
yeah.
than I'm getting. It could be where it's located, could be the balance was off, could be maybe a hand valve was shut, could be a bunch of things.
Yeah.
So
there could be a problem with that one.
So yeah, we can see right now is
Where's that?
the valve. This is dorm 279.
And that's in building what?
That is in building 73.
Just the corner.
So we can see that the discharge air temp is 55. The hot water valve is saying it's at 100%, and we're not able to maintain the supply air temperature.
Yeah.
So valve is probably closed, hand valve is probably closed, or maybe there's an issue with the actual actuator.
It's not working or something.
It will keep a track of who's been calling for it the most. Basically your worst perpetrators of needing more. And those would be things where if it's way out of the ordinary, that means that there is probably something wrong with it. Even if it is working and maintaining temperature, there could still be something wrong with the valve or the like the hand valve maybe slightly closed, the actuator may be failing, hasn't failed all the way, could be clogged up, all bunch of different kind of scenarios that it could be, but they basically tell you, hey, these are the ones you'd want to take a look at. And then we also have the domestic hot water system as well. and this is mostly just monitoring. It's all pretty much self-contained, and we just read some values and flows. And then what we do is we also try to maintain a differential pressure to these to make sure that they have enough heating hot water to be able to heat the domestic water.
Right now, I guess both of them are running, but real small flow.
So you will see some flow because of the recirc, and these flow readings are coming directly out of the heat exchangers. I don't know how they determine that.
Okay.
I think they're trying to basically make an educated guess. But I also don't believe that these values that they're giving us are correct, because I don't think we're flowing through 250 gallons of hot water right now.
Yeah, that's quite a bit.
But that's the value coming from the equipment.
Yeah. That's actually the recirc line right there. No.
No, so that.
That's the.
So
that's
again,
just the return line.
yeah, there's a mixing valve. They go to here. There
That's
is a
the
domestic.
cold coming in, my bad.
Yeah. So right now the power user can see what the users are here. I can't go in. If I try to create one, click OK. It'll say, no, let me see. Oh, I am in, let me see. Yeah, so it won't even let me, it won't let me type in the password.
Yeah.
So it won't let me create the account. I can go in and take a look. Let me see. Let me see if it lets you do anything else, like change the name. Sunbelt. Yeah. It says super user, which is an admin level.
Right.
Needs to be, so it won't let you. So it'll let you go in and see the users, but it won't let you actually change anything. Now, if we were logged in an admin from here, these are the like the admin account, and then the user template and the power user. Basically, you would just select this, duplicate.
And then you can name it whatever you
Yeah,
want.
it won't let me actually do it,
Right.
but then you can give the user the name, you can put their email address in, their full name, their account name, set their password. So we try to
And right now, all the passwords are set to password, right?
Yeah.
Capital P with, does it have the 1 and the
Yep.
exclamation point also?
yeah. So whoever's going to be administrating it, they should go in and actually
Change
just
it.
remove those passwords from those accounts, and that way when they're duplicating it, then you just put it in. And then whoever's going to administer it should go in and change the admin account password as well.
Yeah, I don't know what's going to happen if we're going to, I don't know who's going to be the admin, so at this point we're sharing it, so
Okay.
kind of interesting.
And then we looked at the help, and then there's the log out. You know, you always want to log out after you're done with the browser. And that's basically the user interface, which would only be the power user and the normal user, the read-only. And the admin can log in to this view. They do get slightly more information. And I'll show you that. So they actually get this different menu over here that they can look at. They can look at different views of certain pages. It's not quite as powerful as actually being in through this software here, but there is a lot that they can do through it. And that's basically if you weren't accessing the supervisor directly, and so an administrator could do more things behind the scenes. the higher level user. But if an admin needs to log in, I would definitely recommend going in through the workbench, which is this icon here. It will pop up this window, and then it will pop up here. And then you'll see that this is this computer, and you'll see this has a, they call it
This
Fox.
is only accessible from this station.
From here,
correct?
yeah.
You can't access it from the other one that you set up.
So the other one has this software,
right.
and they can theoretically log in to this through that software and get this same view like they're here.
Oh, okay. Another question is,
yep.
say they're logged on to that software there, is that does that lock up this computer when they're using that? How
So
does
that
work?
computer can access the web browser here, but it's using like basically an internet connection and doesn't lock it up here.
Okay.
They can remote desktop into this as well
Right.
from there,
That's what I was wondering if we were.
but
that's
the way
not
that they
nice.
would go in from there would be through a web browser here, and
Thank you.
but basically there is what they call the station. So the station is like the software. It's the whole management system that we built the database in, made all the graphics and the points, the alarms, histories. That's what they call the station. So from here you can actually go in and see the graphics. Essentially everything looks basically the same. Some of the things load slightly different between here and our web browser, where these tabs look slightly different. Let me show you. I hit cap lock. See, these tabs look slightly different between it's just web browser versus natively. The campus home, when you're looking here and you see the schedule, this is actually a different schedule. This is for setting the peak usage time for that energy system, because it is the same across the campus of this system, and that load shedding. So this is this schedule tab here when you're on the campus home is when you set your time of use, and then there's you can have a summer time of use, winter time of use, and determine what those days are of summer versus winter. And again, that was just part of the sequence that was requested for the energy system. But from here, this is a very powerful view. It's also powerful in a way that you can do damage to the system. We'd recommend anyone doing this, going into this type of system. There are trainings that can be done through us to get certified for just kind of being an administrator user. There's also just a 5-day training course just to kind of get into the more of like what we do at our level. Be kind of beginner course that gets your certification as well. And then there's another 5-day for disk tech and the programming in the controllers themselves. I haven't gone in and added all the JACEs yet, so I'm just going to go in. Let's see. Manager. So from this computer, you can access the JACE and their stations and their file structures and database. So if you wanted to go in and take a look at a controller, you can, if you step down to the actual controller, from here, you can right click and do a launch wizard, and it will pop up another one. Now actually get you into the into the code of the program. It is a relatively easy code program to follow. It's all object blocks with links basically between them, and the blocks all have different functions. So you can see there's, and we try to keep everything nice and organized with different tabs for inputs, outputs, and separate logic. From here, you can override points. You can do a live view. You have to look at the data coming in, and you can follow the logic through. So we can see this, like this example here is hardware inputs. So we have our inputs here, we have our values here, and these are values that we bring up into the JACE, which then goes to the supervisor, which we make the graphics on. But through here, there's a whole bunch of different sheets and codes. You can see
This is just for
this is just one fan coil. Yeah.
Yeah.
So this is more just to kind of show you guys what you can do.
Right.
Again, I wouldn't recommend anyone doing this unless they take those classes and get certified.
Yeah, this is
know
more
what
in
they're-
like setup right here.
Yeah, and you know, it can be used for troubleshooting.
I have it turned down.
If someone does do this, it can be a useful troubleshooting tool. If something's not working, you can't understand why from the graphic, you can go in and look at the code and see exactly why a hot water valve isn't being commanded to open, even though you think it should. There could be some sort of safety condition that's stopping it.
Not at this time, Therese. We're busy right now, so we'll have to call it after stuff.
Acknowledge. Space clear.
Restocked on chips, huh?
As far as access, like Foundation has access to this computer with a lot of big facilities in Central Plant.
I'm not sure if they do or not. It's, basically, it'd be an IT issue, letting their computers be able to talk to this one, and then they would need a user name.
As far
So
as
theoretically, they could.
As far as I understand it, just some of the points are loaded into their stuff over, you know, where he can see it.
Yeah. I do know that.
It's just like the
Al-
chill water,
Alex?
the energy.
Is that right? Is that his name? Over at the central plant, Alex?
No.
No,
Uh,
Dennis
yeah.
or Jesse Ochoa.
I do know some of those guys do know more of the background side of
Yeah,
Niagara and the
specific.
controls. Kevin, that's what I was thinking of.
Yeah.
Kevin specifically, he's the specific controls guy kind of on campus
Mhm.
for facilities. We don't have a specific controls person, so.
And you guys are all separated out?
Yeah.
Okay. Wasn't sure how the whole
Yeah.
separations work.
That's why it's kind of silly that they built these buildings and they didn't separate this control system here.
Mhm.
So.
Or for there to be like some sort of shared control kind of group like IT that kind of oversaw for all the different groups or something to that extent. And so I mean that's basically the user interface. We can let's see, take a look. You are able to open multiple zones at the same time.
Yeah, the pop-out windows you're talking about.
Yeah. So they set it up so you guys had like multiple screens. You would have
Yeah.
multiple things open at the same time. Let's see. So the common areas, you'll see that they don't have room sensors or window sensors because those windows don't open.
Right.
The other ones, you'll see that they're closed. You can override it closed in case a window sensor goes faulty. You can just get it by until that way they're not, without heat or without cooling.
So if it's telling us closed and it, or it's telling us open and the window's closed, if we shift it to closed on here, if that thing is telling it open still, is the open gonna come back through, or?
So as far as the code and
override
operation, it would, once it's overridden, it would work however you override it, and it would think that that's the state it's in. And then once it was autoed out, it would
Yeah.
then release to whatever
Back
status
wherever
it
is pushing on
was
this thing.
showing.
Yeah.
So you can see like this unit right here is showing condensate alarm. So that state hasn't changed in a long time. That may be that this is a faulted condensate alarm. When they went through and replaced it, they may not have wired it right. I know we're gonna have to work with the mechanicals to go through some of these alarms, and we need to verify one, that's not ours. Want to make sure they're all cleared up for you guys. That way, you're not coming in and having a list
Having
of
a bunch of alarms.
400 alarms
Yeah, I
and
assume this will be done before we actually get the buildings. but-
yeah. So we'll do you guys want to go take a walk and go look at one of the controllers, and we can come back and we'll do a more focused look at each holder. If the fan's in auto, the fan will run in auto. They can turn the fan off, then it won't come on at all.
Right.
They can turn.
Very touchy.
Pretty simple though. That's good.
And the fan will run.
So that tells you the
Sensor plugs in, right?
This is the long communication trunk here, and this is the I/O and power.
Right.
They all get powered from the unit themselves. You'll see that there's a few different lights on the Jace. This is power and like a heartbeat. It should blink kind of constantly like that. That shows that the Jace is up and running, is normal function. We can see these are communication lights here that you'll see for these communication. So this is I think one's BATNAC and one's Modbus, and then these are lawn modules here. These orange type of connections. You'll see they'll communicate and they'll blink here and there. This shows that it has power, and then this is the communication status lights. And then these are the Ethernet lights, link light, and then the data transfer. So if you came down here and say these lights are off, means it might not have power. It does have power, lights us are off, that means the Jace has failed. If you come on power and these lights aren't on, or they're on and you're not getting any sort of blinking, that means that the communication's not working. Or if none of these lights are on, that means that there's no actual physical connection, so maybe the switch that they go to is disconnected. All the data within the building is on its own local network. We had to order another switch, it's not in yet. That will replace that for a panel mounted switch.
Okay.
So the Jaces do communicate between each other for the hot water and the chilled water for the increase and decrease in pressure demand. And that's all done locally. So even if the campus IT network goes down, the building itself will still continue to operate how it should, because it just relies on its local connections.
Yeah, everything's programmed into these necessarily.
Yeah.
It's not talking to the computer all the time.
Yeah, the
getting
computer is not.
settings from
Yeah.
it. The program are all inside of here. And this one is for what?
So these are these are lawn modules. So that would be the first floor, second floor.
Okay.
This one, the smaller one here, with less on it, is the metering Jace,
Okay.
where it does have one controller on it to pick up a DI for the pulse water meter. Then there's a whole bunch of other things. There's relays. There's we have our transformers with breakers on them, where if they overload, they might be popped. So if you come in, you see lights are off, you might want to check all those. There's some stuff in here for like the boiler system, how the boilers communicate, and then we have our controllers. So here, if you know what each output is, so say you went in the code and looked at the controller and said, hey, I know output number 1 is for a fan. So here you could actually turn these on and off, these inputs on and off with these hand switches. And then if it's not a digital, so say it's like on a fan command, it's an on or off. So we're sending out power to a relay or not power. But for say a valve where it's modulating, it's a signal. So if you were to put this into, say this output right here is for a valve, you put that into manual, and then you use a small screwdriver to adjust that, it would move the output from 0 to 100%. There will be full drawings in each panel of everything here that will show you, output 1 is for this fan, is output 2 is for this pump, input 5 is this temperature sensor. We're just waiting for the finished control drawings, and they'll be laminated in a little thing on the door here.
2 to 10 volt DC.
They can be, these outputs can be 0 to 10 or 2 to 10 or 0 to 5, or they can be 4 to 20. If you want to change an output, you actually have to pop this controller off. There's a jumper on the back.
So they've already been preset.
They've all been set for whatever. Anything that's not used would just be by default. I think it's by default a 0 to 10 output. Yeah. You enable the 4 to 20 output. Yeah. The panel in the next building is pretty much identical to this one as well.
So this exact same setup right here will be up in like another closet
Yep.
above
Yeah,
us
just
in the
like
electrical
this
room.
Jace, and it may have
Two modules added
one
to it,
local
right?
controller in there for exhaust fans, or the fan coil for that room. But yeah, it'd be a Jace like this with the 2 modules. We do have one Jace where we're doing a test for the manufacturer, where we remove the Jace and put in what they call an industrial PC in lieu of the Jace, because they're having some issues with the global points, and when we try to do some global points, some of the Jaces are acting up and they can't. So they wanted us to try actually taking the station out. So right now we have that in, and we're waiting to get answers from them about how we're going to move forward with it.
Okay. And this is a problem with our specific job or with another, any job?
Any
that they've
job,
been having
any
problems with?
large lawn kind of setup, which there's not a lot these days, so it's been,
Yeah, you do more lawn or backnet?
Backnet,
or-
100%
Yeah, backnet. Yeah, that's what I expected this to be. I was surprised to hear you say lawn this morning.
yeah, we were told that if this had started like 2 months after, we could have done it backnet.
Yeah.
We just missed the,
Kinda disappointing.
yeah. But yeah, we're waiting to hear from the manufacturer for a solution of the issue with doing some global commands and stuff. And, so we're waiting in, like I said, it's the 8th floor one right now where the Jace has been removed. We have an industrial PC in there running the station, and then we have what they call, instead of these LAN modules, we have a LAN IP router that's doing the communication. but yeah, we're waiting to get a final word of the solution, how we're going to move forward and determine that for you guys. The boilers themselves talk through this field server device, and then they talk to the Jace. And then this device right here is something for the boilers, where it talks Modbus to the boilers and gives them a temperature, a supply temperature set point, or not set point, but a header set point. Basically, this is kind of
between lawn and
so this takes the input and makes it so that all the boilers can read the header temperature. It's from the manufacturer.
because well, they're on a different communication system that we're using for the main control.
Yeah.
So I assume that's
Yeah, and then from there it gets translated to it.
because we have a similar setup on our other stuff over there. That's that controller that's outside over there.
So the panels do have a circuit, a breaker here that will kill power to the whole thing, and then there's another one that will kill power to the 24 volt side as well. If you ever needed to work on it live. A couple power supplies, some things use different voltages, different sensors, and meters require certain voltages. Yeah, this panel right here is pretty identical to the other panel. And basically this is really the only place you'll see these type of controllers, where almost everything else is the smaller 103s. You also see, if you look over here, the data drops for the campus IT that they provided, and we just connected up, and they have their port number and information. So if you do have networking issues, we can give them that information. That will help you guys work with them to solve the communication issue. You guys have any questions about this or anything specifically you want to go over more? We can head back over and do a little closer depth look at the fan coils and the VAVs and the systems.
I don't really have any questions about this. Anybody?
Whole campus.
You're like 5 people. Yeah, that was back when, back when they had the horse trolley
And only
As a
men
shuttle?
were allowed to go to college?
as a shuttle.
They did have the horse trolley.
I know.
That's pretty cool, actually.
Okay, we'll take a closer look at some of the systems and some of the individual types of units as well. So basically, the individual pages that you'll see are, you'll have an air handler page, you have VAVs, fan coils, and you have the heating hot water system / domestic hot water, and then the chilled water booster system. So pump 1 had failed to start at some point. Because of that, I could right click on it and click pump reset pump failure alarm. So now it will try to start the pump.
Did we switch it back to auto before?
I'm gonna have to go back and
I
don't
read
think
it,
we
it
switched
said
it.
auto.
did it.
Yeah, it said it was an auto.
Okay. So from here you can see
turned
the
it off.
yeah.
No, but I looked at the screen and it said it was an auto.
Okay, I'll check just to be sure. So basically, this is kind of just an overview of the system, like the differential pressure coming from the campus, the supply and return temperatures, how much water is actually flowing through the system. If
The
So
chilled
chilled water,
For just one of the buildings.
yeah, each building has its exact same setup.
This is for the building we were just in
Okay.
specifically.
It has
Yeah.
chilled water that's supplied by the campus.
Right.
Yeah,
It comes into us and goes through pumps.
or it doesn't always go through pumps. So the booster pumps are in parallel with the check valve, and they'll only come on if needed. And then you can see what the 8th floor differential pressure is as well.
Yeah, so if they're feeding us enough pressure, differential pressure from up above,
and the water's coming down with enough force to supply the building fine, then the pumps actually won't turn on until there's a differential pressure that drops down below, and then it'll fire one of the pumps, you know, at a certain RPM. And
So when the pumps are running, they'll control to this effective set point.
And what is that?
Right now it's at 5, and that resets based off the differential pressure request resets.
So that's changing constantly, I guess.
Yeah, so it will change as long as there's something to demand for it to change. And again, that's just all part of the sequence here. It's a whole bunch of different settings and time frames and looking at the valves. But it will go from an initial set point of 5 down to 0.5 or up to 20, depending on the demand.
Yeah, that's what I was kind of wondering, the range. So when we look at it, we can kind of get an idea.
In this pop-up, there's also a page for the settings. So in here, you'll see alarm settings. So you'll see like the supply temperature, high-low limit, the building differential pressure alarm. So this is based off a deviation. So this is set for 20%. So if the pumps were running and we were 25% under our right now our 5, so if we were at 3.7, because we're on 25% of 5 is 1.25, so if we're under that for 20 minutes, it would go into alarm.
Right.
Or if we were over, it would then go into alarm. Here we have, so if the DP COM fails, the pumps will automatically just run at 50% speed, just because it's basically a speed where we're not going to overpressurize. We may not be running efficiently, but we'll make sure that everyone's getting the water that they need. And then again, there's a maintenance reminder for the pumps. With right now they're set 10,000 hours. There is also a global command here for the valves. So from this point, say in the future you guys wanted to do a flush of the whole system, you guys could override every valve open. You could override every valve closed just from here. And then this is the settings for enabling the pumps that was part of the initial sequence.
You got that in settings right there.
Yep,
right?
settings.
Click on settings.
So this is the graphic view, the settings, and then the differential pressure requests, where you can go in and see like which one is, you know,
Request.
all the different units, which one.
Dan coils.
Yeah. So from here, you can select the different floors and see. You can see which ones have been the worst ones out of all of them, what their units are, how many hours, etc. Do you guys have any questions about the chilled water system?
I just campus is supplying the cold water, that's just for the chilled water, air conditioners. Do they have access to looking at some?
That's what we asked them.
Yeah. As far as I understand, they have access to see into like flow meters for that and stuff like that, because they have to.
Right. They don't have
based
access
on
to
that,
this
but-
whole system we've been looking at.
No, I don't think they have access to our pumps and stuff like that, but they could. I don't know the specifics of that.
But it would just be focused on chilled water, but they're supplying us. If
Right.
they have any type of.
Right.
I know that they will have a user account to get in to pull that data, and read that data into their system. The other main system that we have here is, nope, I want to do a click too fast. Yeah, is the heating hot water system. So we have 4 boilers. We can see right now we have a minimum flow. So it's saying that we're not flowing enough minimum water, but we are trying to bypass to raise that flow up. why we're not flowing enough water, I'm not sure.
That's for the boiler
For the
specifically.
yeah,
And how are we getting flow for that? Is there actually like a flow meter?
yeah. There's a
there
flow
that's-
meter.
that's actually
It's a
telling us
turbine
flow? Yeah.
style flow meter. It's actually part of the. I believe that flow meter is part of the BTU metering for the energy of it as well. So it's that flow meter, and that it looks at the supply return temperature and determines how much energy is being used.
That alarm in boiler 2, can we clear that?
So no, that's just
It's an
physical
active one.
output from the boiler.
Okay.
So
we can't actually clear it from here
no, let's see.
because it wasn't showing alarm over there.
It wasn't.
Mm-hmm.
Yeah, I'll
At
have
least
to-
not that we saw, right?
yeah. I'll have
It
to
was
take-
actually running.
Okay.
2 of them weren't running and 2 were, right? Is that how that
Yeah.
operates?
Have to take a look. Yeah, because it's saying that it's no alarm. I'll have to take a look to see. We have a supply temperature reset based on outdoor air temp. That it's there. It wasn't part of the sequence. It's disabled. But if that's something you guys end up wanting to enable, it's just a matter of setting it and enabling it. Where the outside air temp, I know it'll send 55 to 60, it'll send 130. Pumps work the same way. Yeah, each pump you can actually click to get more info from the drive. And same with, I forgot to go over this with the chilled water, but from here you can see if it's already the drive. Actually, let me take a look. Okay, so yeah, that's still in handoff.
Yeah.
So I have to go over and set that
Yeah.
back.
I don't think we changed it back to auto.
So we have 2 things that will drive these pumps. It's the whichever one is the least, or whichever one has the most demand, either keeping the DP up at the differential pressure for the domestic hot water heat exchangers, or the 8th floor. So we can see right now our effective set point for the 8th floor is 0.5, but we are over it. So that's not the driving force.
And that's the differential.
It's keeping it right here.
for the-
So whichever one needs the demand will be the driving one. So if this was set to say 10 psi, this may be 12 here, and it would be fine being 12. It's just like the minimum it needs for flow to keep up with the design load.
And that's for the hot water system right there.
Yeah.
It's set at 2 psi differential.
Yeah. So, and again, I'm not sure why flow seems to be low. I'll have to take a look at that, but and this alarm here. We are maintaining our DPs. We don't do anything to increase flow except for open this bypass valve. So it could be something that maybe someone might have that bypass valve. Yeah, there may be a hand valve there that's closed. Again, we have a settings portion of the page. A lot of it is, there's a lot of alarm set points. Some pump start and stop delays, minimum, maximum speeds, the rotation intervals, a balance override for all the hot water valves in the building, an outside air temp lockout where it won't allow the heating side of this to work above 120. It will still run for the domestic, but it won't, no matter how many.
We have that set at 120 right now.
120. and that again can be set to any
Whatever.
value. Yeah. And then there's a freeze protection, so even if there is no call, the pumps will just start running if it gets lower than 36 degrees out. And then again, we have the differential pressure requests, so we can go through and again, it's kind of basically the same thing between this and the chilled water system. It goes out, looks at all the valves, see if any zones are requesting additional, and then it'll reset the pressure DP up. And then we'd have a domestic hot water that's off of this, where you again, this is we're just monitoring all this. We don't control any of it.
From our other diagram, it
Yeah.
shows the
And from here,
2 psi
yeah.
and delta right there.
And from here, we can actually click back,
oh, okay.
and from here you can click over to, or you can click up here.
But it shows that bypass twice right there, right? Basically.
So it shows this
Or
DP
that
sensor.
differential
Yeah.
pressure, I mean.
Yeah.
Yeah.
We can see the heat valve. It'll open up if it needs to maintain this discharge temp, and it goes into these tanks and then out. The air handlers are all basically set up the same. They have an outside air flow. They have an economizer, return air. They look at building static. We increase to try to get building static up. We don't do anything to try to relieve in the building static per the sequence. It's a single fan, so we can't really do anything besides open the dampers and singular command. So we can see this one is showing the stuck statics is slightly low. So just like how the pumps work for the chilled water and hot water system, for the air handlers, they will look at their at the VAV damper positions to increase or decrease duct static pressure, and also it will look at It'll also look at the load and increase or decrease the supply air temperature as well.
Based on like cooling requests.
Based on cooling requests. And again, just all the different set points of how often it changes it, by how much it changes it up and down each way.
And the heating coil control on these air handlers, are those being controlled? Is there anything in
So
each of
the
those?
air handlers don't have any heating coil themselves. The VAVs have reheat coils, but the AHU does not have any sort of its own. Oh no, it actually does.
Yeah, I'll argue against that.
Okay.
Yeah, they have a heating coil. That's why
Sorry.
I'm asking, because some of these IDF, and I don't know if we're going to run into a problem with it. Hopefully, all that stuff. Is
I know,
taken
okay.
care of, but we have
Yeah.
these IDFs, and
Yeah. Sorry, I was confused. Now I remember. Basically, the way the heating load works is it's one command will go from basically no demand. There's one thing trying to control the supply air temperature, and it will only heat that. It will only use that hot water valve to bring the supply air temperature to that set point if it needs to.
Okay.
So say if the
If
supply
it's
air
like
set
50
point
or
is
something,
yeah, if the supply
and
air
it's like 30 degrees outside,
Yeah.
then it tries to maintain.
It'll
that
maintain,
55 or
whatever that set point
whatever.
is. Sorry, I misspoke.
Okay.
I jump around from.
Yeah, that's all right. I was just trying to get an idea
Yeah.
because we went in there one day and we saw the heating water was coming through the air handler over there in 73, right? So
Yeah,
That
if it
space
needs to
temperatures
heat
weren't
it
at
up,
set
it
point.
will. there are high and low static pressure safety switches. There's a filter DP.
Is that shown right there?
Yes, right here. Where if it goes into alarm, you can actually
Where does
reset.
that alarm at?
So it will show here. It will show like a flashing red. It will show up in that alarm console as a filter alarm.
But what? Oh, I guess what?
Oh,
button
what
does
is
the
it?
Alarm at is what I mean.
Yeah. So that is
Just wondering.
yeah. So right now it's set for 0.08 inches of static. So we do have a settings page again. A lot of it is there's static or there's a bunch of alarm settings. There's some economizer settings, like when the economizer, when the supply fan's at minimum speed, what's the minimum position for the economizer? When it's at maximum speed, what's the minimum position? We reset that because 20% at minimum speed versus 20% at 100% speed isn't the same amount of air. Some economizing for free cooling. A bunch of alarm settings. From here, you can actually go through and set. You can reset the PID loops for any of those. They should be relatively tuned. They shouldn't really need adjusting.
Self-tune? Is that what?
It's not a self-tune. This actually, you set the proportional or the integral right here. We have a global air wire, so I can from here I can go in and I could set every VAV to full flow, min flow. From here, it's mostly just for balancing. If you were trying to kind of recreate an issue, that might help. Like say something happened on a hot day, and now you're trying to kind of recreate the issue. You could say, hey, send everything to max cooling flow. You can set the min and max frequencies. So the minimum you can set, the maximum you cannot change. The maximum is set by the unit manufacturer, and they're all different. Like one's 81, 167, and 161 maybe. But I know they're all slightly different, and they're all weird. You know, like 81 hertz. I'm not sure how they came up with those numbers, but it's actually listed on the name tag of the unit.
Right. Yeah.
So we
Mike told us about that.
we do let each unit go up to it. Again, we have a maintenance reminder with a runtime, its runtime and how many hours for that. We have the night setback requests. So if during the night, two VAVs request heating, say it gets to, say actually, and these ones now, they never go unoccupied because of the IT rooms off of these. So it's really a moot point. But if they did ever go unoccupied, then two zones either called for heating or cooling, it would then kick the unit on. And this is essentially the same between all three air handlers, between the two in building 74 and the one in building 73. So here is one of the VAV pages. Again, from here, you can override the airflow set point if you want. You can click on any of these icons to get the airflow history right there. You can see what the effective heating and cooling set points are, the space temperature, what mode of occupancy it's in, and you can override that.
So if someone changes the airflow set point on this, is there any kind of designation on that? I guess it's going to be in the plans that we
Yeah, be in the
probably,
in
is
the
there any
plans.
kind of designation on the unit too of that airflow or anything? Or
Not that I'm aware, because really it's more of the box size determines kind of what its flow scale is.
right?
But sometimes it can be really maxed out, and other times it can be barely using any of the. That's one reason why we do try to reset the damper position, so that way the dampers can try to be mostly open. We try to take the worst one and make it be like between 85 and 90% open, and then reset the static to have that one. Because the less, same with pumps and valves, the less restriction, the less that the motor has to work to move the same amount. And again, we have a settings page for this. From here, you can say if you found in 5 years one of the room sensors was reading a little off, you could put the space temp offset. So if you go in, you measure, oh, everyone else is reading, within half a degree. This one's reading a degree high. You could do an offset there.
Someone would probably have to be here, and someone would have to be over there, so you could probably.
Well, so the VAVs would actually show on the display. So you could compare it to the display is whatever this offset would be. So if I took this one here, which is reading 71.8, and I put in an offset of 5 degrees, if we went to that stat, it would then show 76.8.
I guess I was thinking more in the fan coil terms.
Yeah, the fan coil, there's no way.
You can't, there's no view of the
View or
segment
anything to that.
like that. It's just.
Yeah. And then there's PID loop settings, discharge air temp sensor offsets to, discharge temp alarm set points. If it's allowed to go into an optimal stop. You have your airflow set points here, which are based off your balancing, which I can tell you some of these zones, they seem like they need more air for get the zone up to temperature.
Yeah.
And then from here too is also the maximum discharge air set point. With VAVs, you don't ever want it to be too high, because then a lot of the times the hot air will just kind of stay up. So I would say maybe not go above like 105 from my experience of a discharge for downdraft VAVs for reheat. But that would be another thing. Some of those zones that are cold, maybe the discharge temp needs to be risen up a little bit. You would also want to look to see if are we at our max airflow, and are we at our 90 degrees now, and our valve is 100% open? There's all kinds of things to make those adjustments.
Some may or may not get above that, or depending on the size of the coil, the airflow that's coming through it.
But right now everything is per the engineer spec. And I do know we just sent off a bunch of the histories, so they'll see that, and it should come up as a flag for them, and then they should say, oh, we need to make some changes here, and they'll probably shoot back to the engineer and say, what would you like us to do here? And it's just one of those things where I know what I would do, but I just can't make those changes and kind of till it's turned over. What's this? Pick fan coil. So with the fan coil, chilled water, hot water, both of those can be overridden. They are just outputs. There is no feedback from those. So if we're commanding it to go to 50 in the valve instead, there's no feedback on that. The only way you would know is basically when you weren't able to maintain the supply temperature. And then what I would say, what you could do if you ever wanted to test, a good example would be maybe put the fan on low, override both valves to 0. Your discharge air temp should be within a couple degrees of your space temperature. And then override one of the valves open, see if the temperature drops or rises. Filter is just a maintenance reminder, so there's nothing that actually monitors the differential pressure across the filter. You have your occupied heating and cooling set points and your unoccupied heating and cooling set points. and then you can see here the set point offset. So if we went over there and the user turned it up, you'd see this would change here, this set point offset. If they put the fan into auto or off, speed 1, 2, or 3, it would show here. And then in settings, we have our PID loops for our hot water, cold water. We have our supply fan, the different some different settings, like if it's on and occupied, that can be changed. That can be changed globally. Alarm ranges. There is a window open alarm, so if the window stays open for 14 days, it will shoot an alarm off to you guys. So whether it's tripped or someone just has their window open for 14 days, yeah, I'll let you
Once
guys
that
know.
alarm comes through, can we clear that without closing the window?
I do not know. I'd have to look at the code. I can look at the code and find out.
Yeah, some of these people just crack their window once they get in the room, and then that's it. It's just open the rest of the.
So not if they want to use AC now.
Well, yeah,
It's gonna be
yeah,
different
true,
now.
true, but
Will the heat run with the window open?
no, nothing
No.
will run. It actually, the thermostat, there's lights that are lit up. It'll actually go blank once the windows are open.
Right, but so
This
if
is
somebody
for-
just prefers that through the winter,
Yeah.
you're gonna get the alarm.
And this is
after 14
for
days.
the resident rooms and the faculty apartments, coordinator apartments. So they do the same thing. It's all windows.
So if somebody prefers to just have their window open all times, we're gonna get.
Does it have to be locked once it's the window? Or
I'm
does,
sorry,
it
what's
have
that?
to, does it have to be locked or just
No,
closed?
it's just closed.
Just
It's still
closed all the way
magnetic.
through, yeah.
And that's something that could be changed. Global settings. You guys could set that to 365 days. Before it goes off. It is something that can be set globally or individually too. If you guys, if you do find some of those are, just one occupant.
So that would be
Just
in
wants
that,
it open.
in that all fan coil
Yeah, so,
global
yeah.
setting.
Yep. So in this under the system summaries,
Yeah.
all the way over is the global options. And let's see.
All the way to the right.
Maybe it's dorms
Okay.
there, because the common areas don't have
Don't have
it.
it.
Infrastructures don't, so it's just the dorm fan call-offs. So you could go here and set that. And right now we're having an issue with the JACEs with the global set points and the load.
Yeah, like
Um, But it's all there for it to work, and once we have a solution,
so
it
these
will be-
dorm FCUs, when we go into dorm FCU also, and we try to do something in there, does that modify all the coordinator apartments and stuff like that?
Yes, if they're, because they're not; those aren't set up as a common area. There's
Okay.
only 3.
So it's part of
Set-
the dorm.
yeah, part of the
It's part of the
dorm.
dorm. It's a dorm FCU, I guess. you
Yeah.
would call it. Okay.
But then you can go back in. So say you wanted to make
Yeah,
the
we
change,
would have to go back
you could
in
then go
and
back and
reverse
change.
whatever we did on
Yeah.
those if we didn't want to change it on those
Yeah.
or something.
Um, you will see as the valve opens up, you'll see like this one here, that there's a little bit of red, and it will kind of scale up. It only goes in like a quarter increments up. Same with the chilled water.
Okay.
The fan will turn, and the fan showing, and
Yeah.
again, we actually do read status.
Yeah, that's right. Yeah, we talked about it.
Yeah. Do you guys have any questions on the individual pages at all?
Not really. Starting temperature was what, 65 for air conditioning on the fan coils?
Yeah, so let's see.
Right, once it's initiated.
Oh, wait, sorry, I'm looking at the. No. Yeah, the initial set point
Yeah, 60.
is 65.
Yeah.
maximum is 65, and the minimum 55. So it'll start there and then work its way down.
55. Okay. Just wondering
Because the idea is once it kind of starts needing cooling right away, they should need a huge
yeah.
dramatic change, and then if that load increases, then it should be able to decrease down.
You were mentioning the condensate sensor, so it'll go into alarm if that condensate sensor is tripped?
Yep, which there was one that was showing that. I don't remember what floor it was.
Which we don't know if they maybe didn't
Right
change
here.
it, didn't wire it in properly, or
Yeah.
So those go back to those controllers that like we saw in that box.
Mm-hmm.
It's wired back to that controller, and
Yeah.
that's how we.
So
do
this
it
one
here.
is all off because the condensate alarm is active, so it won't allow it to run.
And I think they're just a float, is what they are. It's just like a float sensor.
Yeah, flow switch.
So
The outside air temperature, humidity, that all comes from the dining hall building. Those units up on the roof there are 100% outside air. So that one has outside air sensors on it, and those values are being brought over here to the network to go up. Not that there's a lot of things that utilize that value, but if you do ever
that's
see
not
that
like
that
outside air and
yeah.
stuff like that, or outside air reset or whatever.
Yeah.
The case. May
I know
be.
like the hot water isn't actively using that. I don't know. So like basically the only thing that would affect is the economizers on the AHUs
For free cooling.
for free cooling. Yeah.
Such.
And by default, if those values fall, it'll just assume it can't free cool. That way you're not wasting energy by bringing in hot
So
air
if
and then
we
having to
split
cool
the
it down.
system, say, I'm gonna of course complain to my boss that we're.
Well, we could
we
could still send that value.
to it.
Yeah.
Okay, that's what I was.
And really, adding a sensor wouldn't be a huge thing either.
Yeah. I mean, I don't know. We may have it like this. I don't know, but of course I'm gonna complain to start with, but because
Yeah, I get it.
it's just kind of a silly thing.
Yeah.
But
Do you guys have any other questions? Anything you guys want to go over more in depth?
The valves that allow water to go in, one of the problems we have here is, for instance, sometimes that hot water valve will leak by, causing us not to get as cool a temperature. Is there any kind of alarm for that, or we're just gonna have to go by what the temperatures are being?
So there is a supply temperature alarm if it's not maintaining supply set point in an active mode. The supply temperature alarm isn't activated unless one of these is active. So there's nothing in there that would show that.
But there's no actual feedback from the valve.
There's no
saying
feedback
that,
from the
yeah.
valve.
Okay.
It wasn't what they spec,
Requested, yeah.
and then
I
without
assume
that
it's just a
spec,
straight up
that
limited 10 volt DC valve, and all they know is they're just getting this input of the low voltage.
I mean, it was entirely up to me. I would always put valves with feedback and actuators with feedback.
It's a lot more expensive.
Yeah.
But there's no, are there any there's no water flow meters in each individual fan coil, so we don't know if strainers are clogged or not, nothing indicating?
No.
Okay.
Just like you said, if the space temperature is not maintaining, then we'll get an alarm, because of course at that point, if it's calling for heat and it's not making that heat, then after how much time is there predisposed time of that?
For the space, so the space
if
temperature
the
alarm.
space temperature is outside of a certain
yeah.
value.
So it's a 15-minute alarm. So say the unit was disabled or went into unoccupied because they left the window open or whatever, then there's a 30-minute delay for the alarm. If the system's just been running and it's been active for over that 30 minutes, then the alarm is a 15-minute alarm.
So if it's outside of the space temperature by wide range after 15 minutes, then I guess it's going to throw an alarm. So that's pretty fast.
And then you were saying there's a maintenance being scheduled.
Yeah.
And that's only, like for instance, that would be for air filters, right?
Yeah.
If there, you got multiple maintenance schedules where you can set like strainers or put.
No, it's just there's
we
just
can say
one
we
maintenance
clean
for
the
mon.
strainers or
It's
something.
basically saying right now it's really based off
Just
the
says
fan
ma- just says
runtime,
maintenance for runtime.
Okay.
so it's really for the fan.
And is there any way we can attach notes? Say, oh, we just cleaned the strainer in 219 or something, and pull up a log of maintenances that we've done.
So there are ways that we can add so that there can be individual notes per the units and on the page. It wasn't anything that was part of this,
And I think that would be
but that's
pretty cool.
something if, and it can, I'm not sure exactly how, because I don't really ever deal with the contracts and all that. But if there are some things that you guys wanted, it could be requested, and then you guys could ask us, hey, what would it cost to add this to the system, and then we could get you guys a price.
Is there
do
some
that.
sort of maintenance thing where you could do that?
We can definitely have, so each unit could have its own notes page, and it says a text box that you guys could type in whatever you
I
want,
see.
and it'll just be there. And that could also have a history on it, so anytime it changed, it would record that information, and then we could make it so that you could click on that and pull it up. Normally we just have like a notes page, and it can just be there. But if you guys did want maintenance reminders on like strainers after so many hours for each valve, there could be ones for those. It just wasn't part of the.
Yeah. Because like right now, we just write down in a notepad that we keep, but it'd be
Yeah.
nice if we could click on a unit and say, oh, we just cleaned the strainer on, but
Yeah. Yeah, but that's definitely something that could be utilized and implemented here.
I think these are. Have you looked at any of the fan coils? I think they're Bolinos, right? Did we look at? So the Bolinos should have a manual override. So I mean, to check for, we could check from here. Like if your question was about like how do we know if they're leaking by? I mean, manually we can shut them off. You can shut them off from here. And then you would just look at the space temperature and see if it's changing because we can monitor the space temperature.
Or even the supply temp.
Yeah, the supply
just
temp, I mean.
Put the fan on low speed, override both valves
Yeah.
closed, and
So
see.
from here we could technically see if there's a problem with the valve before we even go over there, but
And and there's all kinds of things that we could utilize. We program jobs for whatever sequence they give us. We could definitely put something in. We could change the program and make it so that if the supply air temperature was 5 degrees outside of the space temperature, and the fans running, and it's like that for more than 20 minutes, it could say, hey, there could be a valve leakage
Yeah.
issue. It's just
I think
one of the
alarm
things.
is
Yeah.
probably okay. I mean, yeah, it would be better to be more precise, but
I'm just asking if it has to keep a bit.
yeah.
Basically.
Yeah. So with this, we could do anything. It's just
What has been asked.
what has been asked, we provide,
Has been
and then and if you guys do have requirements, it's definitely something we work on the campus a lot too.
We're almost to the point, like, you guys as the building service engineers could see that and say, oh, you're going to need a valve or
Yeah.
anything
Yeah.
else would be, but-
And if you guys came up with like a list of, hey, what would it be to implement these?
Ideally, it would be nice to see this system integrated with our old system, eventually, but I don't know if that's going to ever happen.
And like this server could eventually, like, so say in the future other buildings came online,
Yeah.
like this server and this program could be taken out, put into like a virtual server that was hosted by IT or something that's heavier, a little heavier for the hosting abilities, and then you could have it all on this one. And
His idea with this, does this have to be running all the time?
yes, this computer has to be on all
for
the
them to
time.
be able to see it at
For
least.
yeah,
And for us to be able to see
all
it,
the
of course,
graphics are in this
obviously, but-
machine. None of the graphics are
If
hosted
we,
locally.
if we shut it off, if the power goes out here, then that's
It will
stuff-
automatically restart
Yeah.
and reconnect everything. You don't even have to have someone logged in for that. It's
Okay.
part of like the background services now of the computer.
Okay.
So as long as the
So
computer
ideally, this should be
powers
like
up.
on a UPC or some kind of backup power.
Yeah, but again, if the network isn't
Yeah.
up or on, whatever switch isn't
Oh,
on,
yeah.
it wouldn't matter
So if
either.
the power goes down on the network right here, then it doesn't matter because it won't communicate anymore. Unless there's a UPS in there, which I don't think there is, but maybe.
And this also is not necessary for the system to run.
Oh.
None of the logic's being done here. Besides just some like when you reset an alarm, stuff to that extent.
So Foundation wants to get into it on their side though. From whatever computer they're using over there, this has to be on. So like if this shuts off and they still have power there, they're not going to be able to see their buildings,
But
right?
yeah. But you can unplug this, leave it off for 10 days, and the buildings will still run as they're supposed to.
Yeah, everything's programmed on the outside, and this is just the graphics and everything.
Yeah, and
there's
the
some
alarm
set
and
points
history
stuff
hosting.
that you can set here,
Yeah.
but everything is kind of coming back from the other side.
The alarms or the histories are set to record for over a year, and they've been up and running for about a month now. And they used up like 140 megabytes of space, so in a year it'll use like a gig of the storage, the hard drive, which is nothing on new computers.
Yeah.
And then it'll rewrite
And then it'll
itself.
just start erasing the older stuff and kind of rolling over. And if you find if there's requirements, you guys need that for longer, that can be changed. It's not anything through the graphics, but we can do like a batch change to all that to keep it for longer. The intervals I think are set for 15 minutes, so it records like the space temp every 15 minutes, damper positions, all that. We try to make it very intuitive and kind of user-friendly to kind of navigate, and different ways to get around, and different ways to kind of look at the building, whether visual through like the different floor plans or the summary page where you can kind of just look and say, okay, like here I can see, okay, everything looks good except for these 3 zones. I don't have anything flashing red, no alarms. This one's just warm. This one's cold. This one's slightly warm.
And this may be a dumb question, but what are the chances of like those? Because I'm not real familiar, super familiar with controllers and stuff. That they're gonna stop making like those those replacement parts that are supported by this. Are there gonna be upgrades
So,
we're gonna have to get on this? Or
No one is actively developing anything with lawn currently. And those controllers that went in are already considered legacy lawn controllers through Distech. I don't know how long they plan on manufacturing those. There's been a ton that were put in. I don't see them just saying, because even in say they didn't sell any to be installed anymore. I'm sure just the replacement for failed controllers, things to that extent, is enough that most companies want to keep making money. So if there's enough demand, they'll still make them. It's not costing them really anything to make those now, I'm sure. But there is no future development for lawn on Distech.
It's all BACnet. That's why I was asking him what he does most of the time, and it sounds like everybody's using BACnet now.
Yeah.
So that's why we got this. It's a brand new building, but we actually have controllers that are already being phased out, basically.
With all the construction
Kinda
work
silly.
falling,
But
always happens with our
It happens sometimes where a lot of places will have like a spec, and a lot of times that spec may not get updated maybe as much as it should.
Because I've found like another place that I work, like eventually that system kind of started becoming, because it was continuing where we were using that.
we already
Now.
have. I mean, we already have.
Right. I'm just wondering
Yeah.
if that's what's going to happen here.
So the backbone of the system, not the controller level, but like the JACEs and this is a relatively new, like Niagara 4 is relatively new. and it's like the industry standard for everything right now, and it has been for a long
We're on
time.
Niagara 3 on other stuff here.
Yeah.
And it is gonna require like software updates and stuff?
It doesn't require anything to keep running. It will have updates that they do not happen automatically. You guys are at Niagara 4.8, and then you guys have whatever's left of the initial 18-month software agreement. So basically, when we purchased the software for the computer, and when we purchased the JACEs when the job started, there's an 18-month window of any update and version update you guys get, and it's a main version update. So say in 2 years from now they come out with 4.9. You guys would be outside of that initial maintenance agreement. You guys wouldn't have any 4.9 updates you could do, but any 4.8 updates could be done for free. It's not something that automatically happens, and being that you guys have such a closed loop, I wouldn't really be concerned about security because they're pretty much impossible to access even when you're here, to the point that it was somewhat difficult at times on the job. You know, and we do have maintenance agreements with the campus for like the central plant and that group, and those type of things can be done, and even the price of keeping that maintenance agreement up to date can be rolled into those maintenance agreements if you guys want. And there's all kinds of different options for that. We have places where they have us out like 2 times a month for 8 hours, and it can be for specific tasks or like any issues that you guys find, stuff to that extent. That's always an option. But as far as updates, there's no automatic updates that will happen to that. As far as the computer, I'm not really sure how you guys would determine with IT who exactly is going to administer like kind of this computer itself, and like any updates that they would try to force over the network, or settings and security stuff they would want. That's kind of, we supply the PC and put the software on, and they can kind of determine how they
Usually just let it go until we have problems. So.
Yeah. Well, sometimes I know my laptop, my IT department was like, you have to update. You have to do the updates. And I did it, and it broke a bunch of stuff.
Yeah.
Working fine before the updates, and
That's what I mean, like, we're not even using, you know, and now it's great to have these new systems, but then
eventually, it may need to be like the other, you know, the Niagara that we had on the last one. It started to not work. Some of the functionality stopped working on it, and it had to be updated. But I don't know. As far as this, it's pretty new. Maybe in 10 years or something like that, we might need to update.
So this, with Niagara 3, which was, they called it AX,
right?
It used Java, and Java
And this
through a
is
web
using
browser.
something
This is
different.
using HTML5.
Yeah.
Like, you can't even get, I think you can only get Java to run on Internet Explorer,
That was our
not
problem, so.
Microsoft Edge, not Chrome, not it won't work on Mac, Safari, and it won't work on.
But of course, here we are 10 years ahead of that, where they were using Java on that, and now if they're using this, who knows what's going to happen in 10 years? It might be a problem, you know, getting onto it that they're using.
Well, I mean, right now this is like the industry standard for like all the internet. Like every web page you go to right now uses HTML5.
Yeah.
So I mean, maybe in 10 years you might see something.
Java used to be the standard, I feel like, you know. So here
Yeah.
we are now. We're at something different, and it might become an issue. It's possible, but at that point, we'll have to cross that bridge.
But it'd be a huge. You're probably talking, I would say, probably 20 years until HTML. You couldn't have a browser that would work.
Right. Yeah. Yeah, it would take a long
And
time.
that's probably at that point 20 years.
Jim will be gone.
And you know that, and I think like industry standard, like 20 years is really the lifespan of a control system, anyways. But I have some.
Stuff runs
Yeah.
off HTML5 as well because of that compatibility. It's just much easier. That way.
Yeah.
I know it works. So you just use a modern browser. The browser updates itself. Right.
Yeah. Yeah, it's gonna be a long time before that's. So obsolete that a browser won't function anymore.
Like you were asking about the controllers is what I would be more worried about the controllers than the operating
Well, I did
software.
ask that. Yeah, just
Yeah.
we're just curious, like how long it's gonna be
Yeah.
before we can't use this anymore. Like it just basically is.
Well, as long as we don't have any problems with it,
Yeah.
you know, it doesn't matter. But technically,
I mean,
you know,
it
But once we have
in
to
your
get in to
situation,
change
I would
something,
say it
then
wouldn't be a bad idea if you guys, you know,
add some controllers.
yeah,
like you said.
on the shelf and just have them, you know,
Right.
sealed up in a nice
Right.
sealed container, you know, with some desiccant in it just to make sure everything stay dry, sealed, and you guys had them just in case.
Yeah.
I do know like they stopped with like the old Jaces, and you can't get the old Jaces anymore. But there was also a replacement for those old Jaces. I know they did put all these lawn controllers in as legacy product, so there's no guarantee that tomorrow I could get an email from Distech and they could say that they're no longer going to be manufactured and the stock that they have is the stock. But it could be that they keep making these for 20 more years.
Yeah.
It's hard to.
So say it's lawn right now. So
Mhm.
say we want to go to BACnet, what would that entail if we
Um,
wanted
so-
to change over to BACnet? All new
So you-
controls.
all new
or
controllers. You can't use the same trunk because lawn uses a different bus,
Right.
wire bus, than BACnet. And even now, BACnet, as far as a two-wire communication, is even kind of going away because everything's going to BACnet IP for the most part. So instead of like a baud, BACnet communicates on a twisted pair,
Twisted pair, yeah, shielded.
and that's communicating at like maybe 38,000 baud, which would be like 0.3 megabytes per second. But Ethernet is 100 megabytes per second.
So we're going to the new stuff is with the Ethernet cable, basically.
Yeah,
I
it'd
see.
be either, no matter what would have to change, it would have to have a different communication.
Right.
They do have BACnet controllers that are wireless. You can have the
What does
new.
lawn communicate with?
It's a twisted pair, but the twists
Is
and the
different.
twists per inch are different. It's not shielded, and you can't. Even if you got like a wire that would kind of work for both, because
Yeah.
there's some manufacturers that say it
Say
works
it
for
works
both.
for
It
everything.
just doesn't work
Yeah,
well.
It doesn't work great.
But you can't put them both on the same trunk either.
Yeah, I see.
But there are options if a controller goes down. There are what they call the ECY line of Distech controllers that do have the option to communicate wirelessly, and they do Wi-Fi, so they can connect to access points, or they can create their own kind of mesh network, doing hops between each other to get along. But that's really the standard of what I've seen, especially last year, has been the ECY line, minus like anything government or government securities type stuff. We have a place up north where they build like the heads, the sensor heads for like the drones with the cameras and the stuff that we may be deploying any day now. And like in there, they can't put it in because they have to meet DoD spec, and DoD hasn't approved the BACnet Ethernet stuff yet. But basically everywhere else has been going into these Ethernet controllers. They have nice new sensors on the wall where it's like a little display itself.
Yeah. Interesting. So in 10 years, we don't know. When you're here 10 years from now, maybe you'll have to deal with it.
Service engineer will have to do it.
Yeah, I just I have a house.
Flux capacitor now.
I have a house back in New Hampshire, and I just put all Distech ECY controllers in to control everything. I turn it on and off my well. I drain it down automatically with valves and monitor everything. So I can just all from here I can winterize it and turn the power off, monitor everything, and
But you have to have internet over there.
have to have
right?
internet.
Yeah.
Is
Pretty easy to get internet over there?
I'm in the sticks. Like I'm top of
that's
mountain, end of a dead end road. I have like a single pair DSL line that is only rated at like 7 megabytes per second.
Good enough.
But it's good enough that I can get in and do those things. And when I'm there, I can actually stream like on one show. And,
Oh wow.
and it's enough that I can stream.
Is this something like you can monitor from home?
You could,
It should be.
but it's
I mean,
with IT.
But IT has like this stranglehold on this.
Well, I just know
campus
that's how
that
the
it's-
you know central plant operates, and they
Yeah.
get it
That's,
all.
but that's because Kevin knew how to get around it.
They did
It's something Kevin got around.
because they did get paid overtime if they checked stuff from home.
Yeah.
You know, if they
Right,
needed to.
right.
And we should be able to if we got a call out at the middle of the night, you should be able to get on a screen and fix it.
So we have a way in right now. The campus gave us a VPN that would
Right.
put us on this network,
Right.
and then we can access and look at the graphic. So they could give you any of you guys that
Temporary
VPN. Yeah.
So,
So
we,
there's
would,
something-
we would have to get a dedicated one to get in.
Like a
So I
dedicated-
set one up for the chiller out there because the controllers out there had to be reprogrammed, and I got access for the manufacturer to get into it so they could program all the controllers and stuff. So it's possible, but
Well,
it's
it
just
just makes sense when you can do something remotely. You might be able to save somebody or
yeah.
yourself from coming out here to work on something.
Yeah. And faster response time.
Yeah.
It would be nice.
IT.
Yeah, it's a big
Yeah.
thing.
Easier
IT.
isn't always easier, Jim.
Well, that's what these people got to realize that that's what controller people do. I mean, on the outside, I mean, Del Pauling just seems to be behind.
Roger, now
everything.
you're being recorded.
I don't give a fuck. Del Pauling just seems to be behind everything all the time.
Well, they're trying to protect the campus, and I understand that. So it's that's a security thing. Is what they're more focused on is being secure around campus. So
I mean, there's tricks too. Like they can create like a complete isolated VLAN where from that VLAN you can't any connection can't get anything out.
It's just a
And,
certain specific.
I mean, it's one of the things that's unfortunate. That's the world we live in. That there's a bunch of people who have to make it. Because just think if there wasn't a bunch of people that were going to hack your stuff and steal your data or just cause issues, how much easier everything could be. Any other questions?
That's pretty much it. So there's no easy app that I could download to.
No. The ECYs actually have a Bluetooth, and you can get an app where you can have it like, and then like for like an office, like you got an office at the VAV, and you can have it, and you can actually set it up so that way it say like the president of the campus, was walking around. He walks into a conference room, his thing would automatically know he was there, and he'd have higher priority than everyone else, so it would go to his temp settings
Yeah.
over anyone else.
We don't know what the president does anyway.
So a company bought Distech a few years ago called Acuity Brands, and if you go into any Target, almost all Targets have been changed now. All the lights work basically. It's the same idea of like how GPS works with the satellites and triangulating. All the lights in Targets have like a Bluetooth emitter, and it will if you actually get the Target app, you can get like a map, and it will show you where you are if you enable the Bluetooth, and you can see, and you say, hey, I need to find this, and it'll say, oh, here's the directions, go down this way, take a left, and then it's the third shelf.
Well, you go some places, and if you have the app, you get there, and it'll ask you, oh, do you want to do this, or do the app?
Oh, this is on
show
sale,
up a
and
notification or something, because your GPS picks you up that you're there.
Data is the new gold rush.
Blue light special that came